So I have a linear space and I have a spanning set. Next is an element such that they're scalars, such that x is a linear combination of them. And in particular, you have a non-zero. You have a non-zero coefficient over here. Then you can replace the corresponding thing, the VI that corresponds with the AI here, with x, and they'll still span. So how am I going to do this? I'm going to let y belong to the linear space. And I need to find C1 up to Cn such that C1 V1 plus that plus Ci minus 1 Vi minus 1 plus Ci x plus Ci plus 1 Vi plus 1 plus Cn Vn equals y. So my goal is to find these coefficients Ci. We know there are d1 up to dn such that d1 v1 plus di vi plus dn vn equals y, since b spans v. So since it spans without the x, with the vi, I can get it. So I'm going to leverage these coefficients, these d's, to build up my c's. Since a1 v1 plus that plus ai vi plus that plus an vn equals x, I have that ai vi is equal to x minus a1 v1 plus ai minus 1 vi minus 1 plus ai plus 1 vi plus 1 plus that plus an vn. And now, since ai is not equal to 0, that means it has an inverse. So what I'm going to do is I'm just going to scratch that out and write ai inverse. So I have this messy equation. Vi is equal to ai times all this big mess. So that's going to allow me to mess around with stuff. So what I can do is I can take these d's, d1 v1 plus that plus di minus 1 vi minus 1. Maybe I'll put down y over here. Y is equal to d1 plus di vi, except I'm going to replace vi with all this stuff, times ai inverse x minus ai inverse a1 v1 plus minus oh, this is going to be a lot of writing, but it'll be okay. Minus ai inverse ai minus 1 vi minus 1 minus ai minus 1 ai plus 1 vi plus 1 minus ai inverse an vn plus that plus dn vn. So I have these d's I know work, and I'm just substituting in for this vi. And now I just need to clean stuff up. So I have y is equal to, the coefficient for v1 is d1 plus di times this thing. So I'm grouping all the d1s together. So I've here are all my vi1 stuff. Plus, I'm going to have the same thing here. d2 minus di ai inverse a2. v2, by just grouping all the 2's together. There's a 2 there, there's a 2 right there. Plus plus same thing with I minus 1. di minus 1 minus di ai inverse ai minus 1 vi plus 1. Plus, I'll just go down here. Now I'm on the, that should be I minus 1. I'm on the x thing. What's the coefficient of x? di ai inverse. And then I'm on to di plus 1. That's going to be I plus 1 minus di times the I plus 1 stuff. Di plus 1 plus da-da-da plus dn minus di ai inverse an vn. So for any y, I can do this. And so all I need to do is use the fact that the v stuff spans, and use the fact that I can solve for vi, and so I can get it. So I have v1 da-da-da vi minus 1 x vi plus 1 vn spans v. So, and the key thing is you have to have the coefficient in front of the vi be non-zero, because otherwise I can't solve for vi here. So that's where I use this hypothesis in the proof. That's it. We're done.